Hi there, everybody. My name is John Aratinji, and I'd like to welcome you to our presentation today, GitHub and You. So first off, a couple of introductions. Who am I? Well, I'm the Vice President of the Computer Science Club here at St. Cloud State University, and I'm also a software engineering major. I was originally a computer science major. I started out that way, transferred in with an associate's, and started out in the program last fall. But I switched to the software engineering degree in the spring. And one of the things that we do a lot of in the software engineering degree is group projects. So last spring semester, I think at one point I had 3 major group projects which we were working on. So trying to share code with each other and collaborate was a really, really important part. And that's sort of how I got experience with GitHub. So today we're going to be talking about GitHub, obviously. What exactly are we going to talk about? Well, what is Git? What is GitHub as well? A couple of key concepts about Git, what are repositories, and sort of the life cycle of a change. What happens when you change a file, and how does this help you out in making sure that your entire code base is changed? And additionally, why is it important? What are the reasons that you should be using Git, both personal reasons and professional? After all that, I want to go through a demonstration with you. We're going to talk about some of the common things which we'll be doing in Git and GitHub, kind of go over the common workflow, and then have a conclusion after that, which will just be kind of what's up next for the Computer Science Club, awesome events for you to engage in here on campus and beyond. All right, so first off, what is Git? This is kind of the core that GitHub and whatnot are going to be based off of. So if we look at Wikipedia, they give the definition of Git is a distributed version control system for tracking changes in source code during software development. Now, it's a lot of words, all of it pretty important, but a simpler way to think about it is just Git is a way to share files and track the changes in those files throughout different computers, different users. We can track the changes that everyone makes and manage those. Now, Git is a really widely used system. It's pretty much an industry standard as far as ways to collaborate on code. If you get a job as a programmer, chances are you're going to be using Git. It may not be GitHub specifically. It might be the company's own server has a Git repository, or Azure Web Services has Azure repos. You could use that as well. But this is the number one way for you to share code on a programming team. Additionally, Git is integrated into a lot of different applications. I talked about GitHub and Azure repos. And I mean, there's also just the basic console line way of accessing Git. And basically any text editor or IDE, you're going to see a plugin, really easy to use way to have Git right there in the editor. So you can see, there's a whole bunch of different ways to use this, and a whole bunch of different ways that Git is implemented. But today we're going to be talking about GitHub. Now, what is GitHub? Well, it's a website that hosts Git repositories. It's free to use and very popular. I was looking at projects that use GitHub specifically to manage their code, and we have things like WordPress, which powers something like 60% of the websites in the world. We've got Ruby on Rails. We have Visual Studio Code. The development for all of those are actually managed on GitHub. So very, very popular with some really major projects on there. It has a lot of plugins for IDEs and text editors. As we talked about at the last slide, if you're using Visual Studio Code or Visual Studio, or I believe Xcode has a plugin as well, NetBeans, all of these have plugins which you can just install, and you'll have a way to manage your Git repository, push, pull, commit, all that stuff right there in the editor. So another reason why we're looking at GitHub today. And what we're actually going to be using today is the free standalone tool which GitHub has, GitHub Desktop. This gives you a really easy way to manage Git without having to worry about installing any of the plugins or anything, or using the console commands. So that's what we're going to be using today. And for all these reasons, the ease of use, the wide popularity, the fact that it's free, we're going to focus on GitHub. But you should be aware that there are other options. Azure repos, companies own servers. You may not end up using GitHub in your professional career, but you will be using some variety of Git. And everything should be pretty easily transferable. So now let's take a look at a couple of the key concepts. Well, first up, we have repositories. Now, I've said this word a few times already. What are they? Well, a repository is where your files are located. It's also where the changes for those files are recorded. So the repository contains a hidden .git folder. If you show hidden files, you can view that. It has a lot of information in it, but that's basically where the changes for all your files are stored, as well as a few other things, like branch information. Meanwhile, you just have your folder there. It acts like a normal folder. You can go in it, have your Visual Studio project in there, and it will just have all the files that you have in your project. Now, a repository can either be local or remote. In a local repository, we're looking at just on your local system. Remote, on the other hand, is going to mean somewhere else. Now, this could theoretically be another machine, but generally, in most Git setups, you're going to have like a central server that is going to be your remote repository for each user. So in the case of GitHub, the GitHub server is going to be our remote system. That'll be the remote server whenever we reference the remote. Additionally, a repository can have multiple branches. And we'll talk about this a little bit more later, but the key thing is that each branch has its own files, its own version of the files. So if we need to do development on a file, changing two different aspects about it. Maybe we have our index.html file, our home file for a web page, and we need to add in a couple of different new features. Well, we might create a branch for each of those features, so we can have one person working on feature A and one person working on feature B. And so GitHub gives you a way to actually be able to view all of these all of these branches simultaneously and switch between different versions of the same file. So quick look at that a little bit. Now, this isn't going to be how your folder is going to look, but this is just kind of a logical explanation of what's going on. So we have like our so we have our local branch, local repository, which in this case is the folder C users John documents project 1. So it's just going to be a folder on your computer. And we have a number of different branches in this. So we have our master branch, which has the version 0.1 of the Hello World file. So we'll say that this is like the very first save. We just created this file, we put some code in there, great. Branch A, we've got the same version of Hello World, but we have a different class which we've added. So same version of this file, different class added. That'll be a separate branch. And branch B, we have the hello world, but we've updated. We've made some changes since then. We're going to call this version 0.2. But you'll notice, we have all these things, and via the GitHub desktop application, or however you're managing your repositories, when you switch between the branches, this is actually going to be reflected in your folder. So if you're on the master branch, you'll just see hello world.cpp. If you're on branch A, you will see the same version of hello worlds, but you'll also see class 1. And branch B, you will see a different version of the hello world, but you're not going to see that class 1 file. So it actually changes what you're seeing in that folder as you switch between branches. Additionally, this is kind of showing a system in sync, like we have everything on our local matched on a remote. Just kind of showing, what's the remote going to look like? Well, that's going to be something like github.com/fuegoconqueso, which is my username on there, /project1. So that's how those links will be structured. github.com/username/project name is the general structure for that. And you can see, again, it'll store everything just like the local did. It's distributed, so there's the same records everywhere of all the changes, branches, etc. All right, so life cycle of a change. So when you make a change with GitHub, which is probably one of your major uses, it goes through a few steps. So the first thing is obviously editing the file. So in our example, we take our hello world.cpp file, we make a change, so it's now version 0.2. However, the .git folder, which is tracking all those changes, it doesn't have that change recorded yet. It just has the hello.cpp version 0.1 recorded. So we need to update the .git, and we do that via commit command. So you commit the changes, meaning you save all the changes that you've made and get your local repositories record updated so that those changes will be reflected. Finally, the third step is you push the changes to the remote repository. So we're just going to take these files, and they're going to be sent off to the remote, so the remote is going to be updated to match the local repository. It's a really basic process, 3 steps, but we'll go into more scenarios in the demo. What if weird things happen? What if 2 people change the same file and try and push to a location, to the same remote repository? How do we handle the changes? So before we get to the demonstration, I just want to talk about why this is important. Why should you bother learning to use GitHub? Well, first off, it's a way to efficiently share code. So I don't know if you've ever tried to work on a project and you've just been emailing files back and forth between teammates, but it's awful. I do not recommend it. GitHub gives you a really easy way to share things among teammates, and like that previous slide, in general, it's a 3-step process. So you don't have to try emailing. I mean, if one person updates a file and then another person updates the same file, then you've got to figure out how to merge their changes, and GitHub takes care of all of that for you. So the second thing, why you should use GitHub, it provides a free, easy backup. I don't know if you have ever had a laptop crash or had any sort of technical problems right before you were supposed to submit an essay or something like that. But if you're using GitHub, it provides a way to avoid that single system failure causing everything to go away. So that's a very nice, convenient benefit of it for, I would say, college students especially. If you're working on any projects for classes or personal projects that you don't want to lose, GitHub makes sure that you won't. Another thing is it tracks all your changes. So if you need to revert to any previous point, If you've made a commit of that point in your process, you can do that. You can go back to any previous commit, and also it gives a record of who made what commits. So in one of my software engineering classes last semester, we were asked by the professor specifically to try and use GitHub for all of our code and Google Docs for all of our documentation. The reason being that way, if there's a complaint about this person isn't doing anything for the project, well, we have a record of that right there. So it provides an easy way to revert changes as well as a way to have accountability. Additionally, you will use Git in your programming job. Like, I don't think there are many companies out there who don't use it. If you have a team of multiple people who are editing the same project, you're going to need a version control system. So Git is definitely the industry standard. And this is a bit of preparation for that, getting prepared to do it in the field. Additionally, you're going to have to use it, it's good to have it on your resume and be able to talk about it in interviews. Like, some higher level jobs, they probably expect you to have some experience with Git, or else they'll expect you to pick it up very, very quickly on the job. Other positions, they might have a lot of candidates who don't come in knowing Git, in which case this sets you apart. So just being able to put that on your resume as one of your skills, knowing how to use it fluently, is going to give you that leg up, and it'll also give you a leg up on your first day when you're trying to get accustomed to whatever repository they have set up. Knowing how to use repositories and Git and all that is going to be really helpful. So yeah, overall the big idea is, you're increasing your value as a programmer. You're making yourself more attractive to jobs, and you're also making your life easier. No emailing code, no laptop dies and you lose your project. Version control makes your life easier. And so, that is why, number 6, I'm going to judge you if you don't use it. There is no good reason why you shouldn't get used to using Git in your projects. And, I've encountered some people who are stubbornly hung up on it, who refuse to learn it, but take the time. Learn how to use Git and put it into practice. You'll really benefit later. All right, so demonstration. We're going to go over a number of different things. We should cover most of these in what I show you. For clone are a little less important generally, but we'll go ahead and circle back to the terminology once we are done with our demonstration. Just cover those quickly, any that we didn't touch on. All right, but let's go ahead and take a look at GitHub. So as part of the preparation for this presentation, we asked you to download GitHub Desktop, to create an account on github.com, and to make sure that you can log into that account on GitHub Desktop. Once you've done all 3 of those, if you haven't done them, go ahead and pause the video now. But once you've done all 3 of those, we should be able to go from there. I'm going to kind of fly through this demonstration. So if you have any problems or you think I'm moving too fast, please just feel free to pause the video as needed and kind of go at your own pace. I just want to let those people who are able to breeze it through just go with their speed, and everyone else, just when you hear a step and you're not ready to move on to the next step, just give the video a pause. All right, so first step, let's go ahead and open up github.com in the browser. So from there, you might get a home screen which asks you to log in. go ahead and do so. And we're going to go ahead and once you've logged in, this should be something like your home screen. And over here we should see repositories. Now, if you haven't used GitHub before, this list is probably empty for you. But what we're interested in is the new button. All right, so we've got owner, repository name, optional description. You can set your repositories to public or private, depending on if you want to keep the code a secret. I think there's a limit to the number of private ones you can have on your account. Either that or the number of public ones. But regardless, not too big an issue. If you're really using it that much, go ahead and pay for a version of GitHub is what I would recommend if you're having issues of you needed more of a specific type of repository at the same time. But, okay. So GitHub demo and create repository. Okay, so now we've got a quick setup screen. We could get started by creating a new file, uploading an existing file. Let's go ahead and click on Setup in Desktop. All right, so we're going to go ahead and set up in Desktop. And now we should see the URL. So up here, same as that. This is where it's going to pull the repository from, and then the local path. So you're going to want to make sure that this is something easily accessible. I just have a programming folder in my documents where I like to store things. So from there, and then the name of the project, but anywhere you can find it. Sometimes it sets it to a really weird name, and so you're going to want to possibly change where the default location is. You can do that in the settings for GitHub Desktop. I'm not going to go into that today, but pretty easy to change. All right, so we're going to go ahead and clone. All right, so cloning is just saying, hey, the master repository, the remote repository, we're going to create a copy on my local machine. With clone, you are actually still pointing back to that same remote repository. There's also something called fork, which would be if you forked my repository on GitHub, that would be copying it to your own GitHub repository. Cloning is a little different in that this local repository is still tied to this remote repository, the github.com/flagelconqueso/GitHub demo. We actually had some issues with this on Wednesday. I had not sufficiently tested it, but if you were to clone someone else's repository, like we just did, and then you tried to make any changes and upload those remotely, it would try and save them to that person's repository. It would not give you the option to create your own version of that in your GitHub. So you would end up not having access permissions, and it would fail. All right, so that isn't too important. But what we're going to do is we're going to go ahead and look at the folder. So I have show hidden files on, so I can see this .git. It's got a lot of information. None of it's too important. But what we're going to do today is we're just going to create a blank text document. The name isn't important. I also don't care too much about what is going in here, but let's just get a line of something in here. So this is the original text document. Okay, so I'm going to go ahead and create this file, write a line of text in there, save it, and we'll go ahead and exit out. All right, so if I go ahead and go back to GitHub Desktop, well, now we can see our changes. So you'll see, we've got a green plus for new. It'll be yellow usually for change and a red for remove the file. But we can see, okay, line 1, we've added this text. Okay, so you've got to enter a name for any changes, a brief description. However, GitHub Desktop will do that for you. Not all plugins do. I know Visual Studio's plugin, last time I checked, actually makes you choose something to write here. But for now, I'm okay with that. You can also write a longer description. We're not going to worry about that today. But ways to give information about the changes you're making to files for yourself for the future or for your teammates to see. All right, so we will go ahead and commit that. So again, that is just saving the changes that we made in our local branch. We're making sure that our Git folder knows about the information that we changed. Now, we're going to go ahead and next publish. It's basically the same as push. But we're going to send this off to the remote server. All right. So now if we go back to our browser, and I'm actually going to make that a little smaller so we don't have to keep switching between. All right, so let's refresh the page, and voila, we have our text file.txt. We've got our text in there. All right, now next I want to demonstrate creating a couple of different branches. Actually, just one new branch. So we'll go ahead and create our merge branch. Yeah, I'm okay with, well, we don't need to publish that right this second. Instead, let's go back to our files. And here we have text file. Now, we see that merge example is currently the selected branch. So if we edit this, edit it in some way that you'll be able to tell it's on this new branch. So this is the merge example text document. Great. And we save that. Now if we change back to the master, actually first let's go ahead and commit those changes. Okay. So now we're going to switch back to master. And if we open up text file, this is the original text document. So as you can see, the contents of these files changes when we switch the branches over in GitHub Desktop. Really neat feature. Now, back in our master branch, let's go ahead and make a change to this as well. And I'll show you where we're going with this in a second. But change it, make sure it's not exactly the same as the change you made in the merge example branch. All right, and I didn't really talk about it, but whenever you change a line, it essentially views it as we remove the line and then we add the new line, which is changed. And it also highlights the area which has been added if it is just a change or deleted. But we will go ahead and commit that to master. And we can push that. All right, and did we publish merge? Okay, so we'll also publish the merge example branch. Okay, so whenever you have a branch and it's already published to GitHub, you're going to see this pop up, create pull request. So a pull request is just, well, it's a couple of different things. If we make changes on the remote server and we need to get those changes, that is known as a pull. We fetch to basically update what our Git is saying. We fetch to see if there are any changes, really. And then we commit a pull to grab those changes and move them to our server. But the more common usage of pull, or at least the more important one, is going to be creating a pull request. So we're currently on the merge example branch. Let's go ahead and create a pull request. Now this is going to open up a window in your browser on GitHub. And here we can see we're trying to take the merge example and we're trying to merge it onto the master branch. So all the changes we've made in merge, maybe we're creating a new component. We made that on our branch. We've got it all ready. We've done tests. We make sure it's working. Great. Now we need to move it to the master, which is traditionally where the main program is residing. If you are, developing a project that already has some versions published, the master would be like the main currently functioning set of files for the project as a whole. And that's the stuff that you'll build and send off. So you don't want to put anything on there until it's working. And you'll want to do this in your projects as well. You'll want to have different branches for different people who are working on different things. And then when you're ready, when a branch is working, you're going to want to merge that into the master. Now, here we're getting a message can't automatically merge. We will take a look at that in a second. Now, oftentimes, if you have two files which have been edited on different branches, if there aren't any conflicting lines which have been changed, you will just get a message here, can automatically merge, great, it'll be awesome, no problems. However, if you edit the same line in the same file on multiple branches, you will get a merge conflict. So we will go ahead and resolve a merge conflict in a second. All right, other information on this page, your title for your pull request and a brief description. Again, communicating with the team, letting them know what you've done. But we're going to go ahead and create a pull request. Awesome. So this is what it'll look like. Okay, and this branch has conflicts that must be resolved. So if we click on Resolve Conflicts, it'll open up the web version. I know Visual Studio's IDE has a version that I really, really like. You actually just, for each conflict it finds in files, you just select, do I want A, do I want B, and you could write your own version for that conflicting line as well. But this is the web version of the conflict management. And this is the merge example. This is the original text document edited. So I could go ahead and delete one of them. Let's go ahead and delete that. Okay. So here we have, this is one way I could resolve it. I could have also deleted the other conflict. What I could also do is edit the line. So if there's something you need from both, like two people added parameters to the same function, but you want to keep both of those parameters in the final implementation, then you could go ahead and combine the two in any way by editing the line. But once you've done that, you can go ahead and mark it as resolved. And then you can commit that merge. Again, we're saving the record of this merge. So we stuck the two files together. We resolved any conflicts if they happen. And now we have no more conflicts within the branch. Merging can be performed automatically. So At this point, we could merge the pull request. If you're working in a team, you're probably going to want to do like a brief code review. Just make sure that people take a look at what you're pulling to the master branch and make sure that it's actually working, doing what it needs to do, etc. So real great tool there, but we are going to go ahead and proceed with our merge. And after that, you're all set. The merge example branch can be safely deleted. So we'll go ahead and delete that. All right. So now, as we can see, we just have one branch remaining, and our text file is the merge example text. This is a merge example text document edited. So we kind of combined ideas from both. All right, so let's go back to our master branch on here, and we'll fetch the origin. Oh, look, we found changes. All right, so we're going to go ahead and pull those 3 commits from the remote origin to ours. All right, and if we go back to our text file, hey, merge example text document edited. So we again, that's really all you need to do. If there's updates to a branch that you need to get, we can just go ahead and fetch from the origin. If it finds any differences, it'll offer you a way to pull. Now, there are a ton of different implementations of Git and GitHub. Visual Studio Code has a plugin. There's a plugin for Visual Studio. So what exactly the interface looks like is going to be a little bit different between them. But you should have pretty much the same terminology for each one, and it'll follow the same basic structure. So with that being said, we've pretty much covered all the topics specifically relating to Git. One last thing I wanted to cover as far as GitHub. When you go into the settings for a project, you can manage the access. Oh, that is not the right password. All right, so we can go into the access, and we can invite a collaborator. And this is how you're going to go ahead and be able to invite people to your project who will be able to actually make those pull requests on your repository. So when you do your actual projects with classmates, you'll need to be able to invite them. So just under settings, manage access is where you'll need to go. All right. So that pretty much wraps up the demonstration. I think we covered pretty much everything. Commit, saving the changes that you've made to your local repository. Push, we're going to send those changes off to the remote repository. Fetch, we're going to see if there are any new changes, and we can pull those changes to our repository. Additionally, there's sync, which it combines push and fetch and pull at the same time, if possible. I know like Visual Studio's GitHub plugin has this capability. So if there's any changes on remote and any changes on local, it'll try and handle all those at once. If there are any merge conflicts, it'll let you know and it'll force you to resolve those. But that's another term you might hear in some tools. In addition to pulling to your computer, there's also creating a pull request, which is asking to merge a couple of branches, trying to move your side branch back to the master or to a different branch which it was initially broken off of. There's merging, which is sticking two files together, and merge conflicts, if there's any conflicts between them, resolving those. Fork and clone. Clone, creating a copy of a repository but still pointing to the same remote. Fork, creating a different remote repository of a project. And of course, we have our repositories, local, here, remote on the server, and branches, the different versions of files which you can access, which the master branch, or I've also heard that main branch might be growing in terminology. That's kind of the home base. All right. So, first of all, if there are any questions, I realize this is not a live event. So we're going to, well, here we can present this. So if you have any questions, please let me know via the Discord. You can also email me. You have my name. It should be findable in the SCSU emails. Or any other way that you can get a hold of us, feel free. Want to help you out, make sure that you are successful with this. As far as upcoming events, we've got a few things coming up for the Computer Science Club. September 30th at 3 p.m., we're going to have GeoCom, a local employer here in St. Cloud, talking about using Amazon Web Services. So come on by, get to know a local employer, maybe make some connections. We will be having a watch party in ECC 117, like our normal in-person meetings, but the actual event will be via Zoom. So feel free to join in person in the room, hang out with people, or you can just join remotely as always. October 16th, that'll be a Friday at 1 p.m., we're going to have an AMA with a Google software engineer. So definitely check that out if you're at all interested. Ask him about what it's like to work at Google, or even just as a software engineer. Questions about the hiring process, like what kind of questions he got in interviews, or what were the interviews like at all? I mean, so many questions you can ask. Come prepared to hear about it and bring your thoughts and what you're wondering about. Additionally, October 24th to 25th, we're going to have our hackathon, Huskies Hack. So this is going to be an awesome 24-hour event. You are given the task of creating a piece of software based on the theme, which is Connect. We initially chose this before COVID, but it's even more relevant now. Every day we connect with, the people around us, with technology, with the world. How can you build software to help us connect? So definitely check that out. We got hundreds of dollars worth of prizes, free t-shirts for everyone who enters. We've got 3 employer sponsors who are excited to meet you, so bring your resumes. But really a cool event to build up your resume and get some experience with just creating something from scratch in a relatively short time frame. Other events which are not hosted by the Computer Science Club. So the 25th has already passed. It was relevant when we made this slideshow. But September 30th, from noon to 1, there is going to be a panel held by COSI, how to connect with potential employers. So for that, they're going to have a panel of employers, and they're going to be talking about, what can you do to stand out in a resume, in the interview process? How can you build those connections that are going to help you get that internship or job? So definitely worth checking out if you have the time. And October 7th is going to be the virtual COSI job and internship fair. So I know that a lot of employers have filled up. There aren't a lot of spots going around, but if you're interested, definitely check that out for any employers who still have some spots to talk. Additionally, it's a good way to see some businesses which are relatively local and kind of see where you can apply for internships or jobs. Most of them will have postings up on their website. If not now, then by the 7th. So definitely check that out if you're looking for an internship or a job. That being said, join the Discord if you haven't already. Not going to post it on a public YouTube video, but we do send it out with pretty much, I think, all of our emails Well, all of our newsletters at least. So sign up on Huskies Connect, and we will go ahead and be blasting out newsletters soon enough. You can also get in touch with us through any other means, and we'll be able to get you that link if you do not have it. Additionally, our weekly meetings every Wednesday, 3 p.m., ECC 117 or via the Zoom link. And about every other week, we'll have presentations. We'll have, last week and this coming week with GeoComm. So we got them back to back occasionally. But we'll have presentations every other week or so, and casual gatherings on the weeks where we don't. So definitely recommend you come out, even for the casual gatherings, chat with people, get to know your peers, and also, if you have any issues or want advice with homework, personal projects, there's a lot of experienced people who show up. So with that being said, thank you so much for watching this video. Thank you everyone who attended on Wednesday. I apologize again for the technical issues we faced, but hopefully this video fills in any of the gaps that we had left. So thank you, and I hope to see you there on Wednesday.